Hey guys, welcome back to this C++ series. In the last video we discussed what variables and data types are. We did not go through each and every flavor of each data type, but we for sure covered the ones that are most relevant for us at the moment. And in this video we'll take a look at literal constants. So first, let's create a new project. I'll name this one as literals underscore and underscore constants. Okay, so now let's see the code that we used for adding two numbers, which was int a is equal to 6 and int b is equal to 6, and then we stored the answer of a plus b in a new variable called c. So this will be int c is equal to a plus b, and then let's print value of c using stdcout. Let's run this and make sure that everything is working fine. Okay, so now the numbers that you see here, 5 and 6, are known as literals. Basically, these are the symbols that allow us to represent standard values in our code. And there are multiple types of literals in C++. For example, this 5, 6 and all other numbers are called integer literals. And keep in mind that you cannot assign values to literal constants. Like you cannot write 6 is equal to 5. This will not compile. So literals are constant and cannot be changed, which also means that literals will always appear on the right hand side of the expression. The next type of literals are floating point literals. For example, in float c is equal to 4.5, 4.5 is a floating point literal. To be precise, 4.5 represents a double by default. And to let the compiler know that this is a float, you'll have to add the character f at the end of this literal. Similarly, in float d is equal to 0.523f, 0.523f is a floating point literal. You can also have double e is equal to 45.65, where 45.65 is also a floating point literal. So, the important point to remember here is floating literals have to end with f. Next type of literals are character literals. Examples of this will be char f is equal to d or char g is equal to z. Basically, these types of literals are just single character. Then the next type is string literals. An example of this will be std string str is equal to hello world or char str2 square brackets is equal to hello world. Here str2 is called an array. We'll discuss strings and arrays in detail in some future videos. Right now, just understand that here hello world is a string literal. And notice that character literals are always in single quotes and string literals are always inside double quotes. Next, we have some escape codes. Basically, these are some special type of literals which have special meaning. Here is a list of all the escape codes and their meaning. I'll put the link to this in the description. These codes allow us to represent things like new line, tab, vertical tab, etc. in our code. Then next we have Boolean literals, like bool flag is equal to true or bool flag 2 is equal to false. As you can guess, there are only two Boolean literals, true and false. And at last we have pointer literal called null ptr. Sometimes it is also called null pointer. Again, don't worry about pointers. For now, just remember that null ptr is also a literal. So these are all the types of literals we have in C++. So next, let's see what are constants. For that, I'll remove all this code. Now let's store sum of a and b in an int called c. I'll print the value of c to console using stdcout. Now after this, I'll write a is equal to 10. And then I'll again store a plus b in c. And let's once again print the value of c to console. Now if I run this, you can see that it says value of c is 11 and then new value of c is 16. This is because after printing the answer first time, I changed the value of a from 5 to 10. This means we can change value of variables while the program is running. But what if you don't want this to happen? What if you want the value of a to remain 5 throughout the program? You can do this by adding the keyword const before int. And now if you build this program, you'll get an error saying that assignment of read-only variable a. This means you now cannot change value of a after it is defined. Similarly, you can write const float, double, bool, char, etc. to create a variable of that type which is constant and cannot be changed in between the program execution. Now you might be thinking, what is the use of creating a variable which does not change? And for this, let's take a look at the classic example of area and perimeter of circle. Here I have a code which gets an integer as input from user and stores it in a variable called radius. Now let's find the area of a circle with this radius. For that, I'll create a variable called area of circle. And from elementary math, you might remember that area of circle is pi times radius squared. And you might also know that value of pi is constant. So you can create a constant variable of type float called pi, and its value will be 3.141, which is an approximate value. So now I can write area of circle is equal to pi times radius. Similarly, you can find perimeter of circle, which will be 2 times pi times radius. And finally, let's print these values to console using stdcout and some formatting. And if I run this and input a value of 2, you can see that we get area and perimeter both as 12, which is very wrong. Now the reason why we are getting these wrong answers is because we have defined radius, area and perimeter as int in this program. So it cannot store floating point values. To fix this, I'll change radius, area of circle and perimeter of circle to float. And now if I build and run this code again with radius as 2, you can see that we get the correct values. There is one more way to define constant values in C++, which I don't usually use that often, but it is also a valid way to do things. So you can write something like this: as define pi 3.141. And now you can comment out this original definition of pi. So basically this is a preprocessor statement just like hash include, which tells the compiler to replace all the places where pi occurs with the value 3.141, like this. And notice that you don't have to write pi is equal to 3.141, and also there is no semicolon at the end of this statement. If you build and run this, you will get similar output. So the bottom line is, whenever you have such values that you don't want anyone to change accidentally while the program is executing, you can mark them as constants. I hope that you now understand literals and constants. If you like this video, hit that like button and consider subscribing for more such content.